They got married on Valentine's Day, so they're like, now they're going to have two birthdays and anniversary and have Valentine's Day on the same day. I said, wait until you hear the last name. Tyler and
Okay,
Valentine.
here's our second example. First thing I want you to do is go through, label your highs and lows, and write at least one loop and junction rule for this particular circuit, then come back. Okay, so I'm going to start with the one I've already drawn a circle in for my highs and my lows. So this is my high potential, this is my low potential. And if I'm saying this is the loop I'm making, then I'm going to go from high to low, from high to low. And then I can come here and do the same thing, and I look, and I'm like, okay, so that's going to have current going in the same direction, so that's nice. This will be high, and this will be low. This is high, and this is low. So starting with my loop rules with my current going that way, what do I get? I get 10 volts equals, let's see, I1, so I've labeled this I2. Let me label my resistors. I2, we'll call this R2. I'll call this R1. And I'll call this R3. So 10 volts equals R2, I2, plus R3, I3. So that's one loop. And now we're going to do the second one starting from the 5 volt source. So 5 volts equals, coming around, I am doing, losing, sorry, too many dings at the same time. This is I1 current, so remember whatever comes out is what comes back in. So if I've labeled this I1, that means I'm going to be R1, I1, plus, and this is going to be I2, R2. I2, R2. Okay, that's two equations. What do I have? I have three unknowns, so I need a third equation. Now I can look at my junction rule. And what do I have here? The junction I chose was I2 coming down this and feeding into I3 and I1. So I'm going to define it just that way. So I2 must equal I1 plus I3. So let's label these. This is equation 1, this is equation 2, and this is equation 3. Cool. Now instead of solving that, let's try another one. Let's just define our equations. In this one, let's see, coming out the high, going in, back in here. So here's my high, here's my low, high, low, high, low. This loop go here, and then if I choose this one coming out, oh, I still have them going in the same direction. High, low, coming back here, high, low. So write your loop and junction rules and come back. Okay, so what do I have here? I'm going to start with my 5 volt equals, let's see, I've labeled this I1. I feel like we just did this one. We sure did. I did it twice. Apologize. So let's choose something different. And instead of calling this a dead battery, let's just call this a real battery. Make it fun. What's going to happen here? I didn't label anything. So give it a go and see if you can define the same things I am. Because now we're going to have a voltage source that we're going to go across. This is going to be fun. All right. So I'm going to start with just this left one, just because. And I'm going to call this I1. Let's see, I1 is going to come in here. And it has two choices. It can come this way. I'll call that I2. Or it can go that way, and I'll call that I3. So I3 is going to come around this loop. I can have a loop in here too. Go from high to low. Let's see. But looky here. Now we need to be careful, because I've defined the one on the left first. So let's put in our from high to low, from high to low. That means if I'm saying current is going to come out of here from this power source, that it's going the opposite direction as to what I defined as positive. Now I'm coming around here. I haven't touched this 0.06 ohm resistor yet, so we're just going to go ahead and label that high to low. And let's talk about what we're going to do with that power source. So I have, let's see, my 12 volts is going to equal, let's see, I've labeled this as I1. I1, let's call this R1, call this R2, and this R3. Equals I1 R1. And then I've defined it coming across here as high to low, so that's still plus I2 R2. And then what about this? What am I going to do here? Pause and think about it and come back. So what'd you come up with? So when I'm going on this loop here, I've labeled this already high to low, right? And what have we said? If I go over a resistor, I go high to low, I'm losing voltage. Well, the same thing is going to apply here. So what this is going to be is my next step is I'm going to lose 10 volts. And then I'm back to where I came from. So starting from the 10 volts, what do I have? Let's see, now I'm going low to high. So before, actually let me write it this way. Before we'd say I went on the I1 R2, so we'll go 12 volts. The way we said that is I'm losing some across I1 R1, and then I'm losing some across I2 R2, and then I'm losing 10 volts across that battery, and that it would equal 0. So if I am starting off writing it in terms of my source, instead of adding them together, I'm going to subtract it. So I'll have minus I2 R2, and then coming across here plus I3 R3. Let's see, what about junctions? What can I do here? I can say that I1 is going to do what? It's going to come in here and either give some to I2 or some to I3. So I1 is going to equal I2 plus I3. So my third equation is going to be I1 equals I2 plus I3. 1, 2, 3. How many equations did I need? I needed 3 because I have 3 currents that I don't know. And then I can solve it. Now, you can ask yourself, well, we'll be able to see mathematically how much current we're going to get across this section. So how strong will I2 be when I have a push and a pull? So I have this voltage source trying to send something out, and then this voltage source trying to send some current in. So how much is that? We'll figure that out. Let's do one more. Okay, so pause and label them. High, low, high, low. Let's see, I've already labeled these currents, so I'll make this a loop, and I'll make this a loop. And so I'm going to start with the top one and let that help me define what is high and low. Plus, minus, and then back. Let's see, so this one, so see why it's important for me to label them right away, because again, I'm going to have current going across the resistor in the opposite direction. Over here, though, I didn't have any current going that way, so I can go plus, minus, so those stay consistent. Now, as far as seeing my voltage sources is concerned, let's see, I can do one loop rule, 2 loop rules, 1 junction. So I don't actually need to account for adding or subtracting those 2 power sources. If I wanted, I could do like an entire loop this away, then come back, and then come all the way back. That would generate a 4th equation. Don't need it, but it is an option. It's a complete, total option. I'd have 2 currents, then, and the 2 power sources. The power sources are values, the resistors are values. So I could solve that one too. totally up to me, or you, in this case. So we can go 24 equals, let's see, I've labeled this I1, equals I1, let's label these R1, R2, R3, R4, R5. Doesn't matter how you label them, just so that you can keep them straight. So here's I1, R1, plus, I was going to say minus, that's not correct, minus R2, I'll keep them in the same order. Color my blue. Minus I1, okay, this is when you know you're tired. That should be a 1. There we go. Minus I1, R2, then minus, or plus, sorry, I3, R3. And then my other one would be 12 volts equals, let's see, I'm coming out. So remember, I am now going from low to high instead of high to low. So this is going to be a minus sign. So I3, R3. Now across this R4, that is in the high to low, so that's a plus. R4, I2. And then finally, plus R5, R2. Now this looks like I have multiple unknowns, but I have I1 and R. What am I doing? This is so sad. My 5. I2. R5, I2. Phew. So I can combine like terms just to make things a little bit prettier to do the math with. Only one I1, R1, plus, oops, not only one, I have 2 of those. So I1 is going to be R1 plus R2, plus I3, R3. And my 12 is going to give me, what am I combining? I have 2 I2s. So I'll have R4 plus R5 times I2 minus I3, R3. 1, 2, 3 currents, 3 unknowns. So now I need my junction rule. I can look at this a number of ways. I'm going to look at it as I have, here's my junction. I1's coming into it and going to I3 and to I2. So I1 is going to equal I3 plus I2. And remember that all that's saying is that I only have a certain amount of current. So if I've defined I1 as splitting into I3 and I2, then that means that I1 is going to be the sum of those 2 currents. That's all this is saying. So if you've drawn it in a different direction or you label your circuits differently, that's okay. Just make sure that you keep track of which one is going into what. If you can say that out loud to yourself, that this current is going in and giving current to both of these branches, then you're golden. Now I have 3 equations. Now I can just do the math with them. And I think I'll hold that off for Wednesday. We'll have fun with that. We'll put it together and we'll solve a couple of these together. On Canvas, I'm going to post a couple more circuits that you can practice with. And do practice that a little bit before Wednesday so you can actually get something out of our work together. All right, see you Wednesday.